Hello, everyone. Thanks for joining me during the lunch session. I know it's always hard to compete with free food, but thanks for coming. My name is Brian Graves, also at Brian Graves on Twitter. I'll be sharing the slides there after my talk for anyone interested. I am the UI team lead at DEG, which is a digital agency actually located here in Kansas City, actually about 15 or 20 minutes south of here in Overland Park. And we do a range of work from e-commerce sites on the Magento platform to Sitecore work and WordPress, and also some work on the Salesforce platform. So this talk is kind of a culmination, and it'll look at some of the things my team has done over the past year or so to kind of ensure we're building fast and performant websites for our clients. So waiting, people hate it. We all know this. Whether you had to fly here to this conference, if you did, I'm sure you got the joyous experience of waiting in line at TSA, or if you drove here, we all know what it's like to wait in rush hour traffic, whether that's trying to get home or trying to get to work. Nobody really enjoys sitting in rush hour. Here in Kansas City, we don't have it too bad, but I have lived in a couple places that have it much worse, and nobody really enjoys this. Or waiting on new episodes of our favorite shows. This is kind of one of the reasons that Netflix and binge watching and all that has taken off, is that people hate waiting for the next season or the next week's episode of their favorite show, be it Game of Thrones or Walking Dead or what have you. And everyone kind of hates this. We hate getting this spinner. We hate waiting on websites and apps to load. Whether it's our Netflix buffering or our search, we're waiting on our search to complete on Google or Amazon, people hate websites with bad performance. And human perception of what it means to be waiting is actually pretty good. So good that we can perceive speed differences in the hundreds of milliseconds. So in his book, High Performance Browser Networking, Ilya Grigoruk actually outlined some metrics for how humans perceive speed and broke it down into a few different levels. So kind of the first level we have is anything 100 milliseconds or less. So anything that's 0 seconds of lag time to 100 milliseconds. To most people, this feels instantaneous. Anything below that 100 millisecond range, we simply just can't perceive the difference in speed. But once we get above 100 milliseconds, that's when we kind of start to notice that there's a wait. At about 100 to 300 milliseconds, there's a small but perceptible delay. It still feels almost immediate to people, but we do start to notice there. Once we get in the range of 300 milliseconds to 1 full second, that's when it starts to feel like the machine is working to people. It's that range where you start to feel the machine chugging along, the app doing something in the background. It's not terrible, but you know something's working and you're waiting on something. And then anything above 1 second constitutes a noticeable delay for our users. Just a single second of wait time will interrupt their thought flow, and our users will start to mentally context switching. They start to think about other things. That could be thinking about why they're waiting. That could be thinking about some task they have to perform later in the day. So thinking about what they're going to have to make for dinner, or what time they're going to have to pick up their kids. Or even what tool they could use instead of ours to accomplish their goal. So i.e. leaving our website and going to some other, which is obviously what we don't want. So because people are so good at perceiving delays in our websites, everyone working on a project should really care about cutting the wait time as much as possible. But in reality, there are really two groups of people we have to care about most and get them to care about performance. The first group is our fellow developers, our peers, and what they kind of care about is shipping good work. They want to create a user experience and a piece of software that they're proud to show off. They want to be able to tell their friends and coworkers, hey, I built this, isn't it awesome? And that greatness is often determined by a combination of difficulty or complexity in building it, innovativeness, or even a lot of times just the experience of using it. Nobody wants to build and show off something that isn't fun to use. But at the same time, our developer peers don't necessarily want to be overly burdened in how they have to work. We can't make their lives so overly difficult by introducing huge blockers to their flow or productivity just to get our performance gains. The other group of people we have to convince is our stakeholders, the very important people, be they managers, executives, clients. And unless you're working on a solo project by yourself and you're the only one that's ever going to use it, everyone's got some form of a stakeholder. And what these people really care about most is engagement metrics. They want to know that their product is going to be successful monetarily. They take a lot of pride in their business, and compare it to others. They want to know that they're beating their nearest competitor in one way or another. And the breakdown of these two groups is really kind of the essence of developing a product or service. You have two sides to any product. One side is the side of user goals, and the other is the side of business goals. Building a good product at the end of the day is simply finding where those two objectives overlap. So what do our users want to do, and how can we monetize that? And performance, conveniently, is definitely something that affects both. So first, let's take a look at how performance affects our users' goals. We know that users are good at perceiving speed, but what are their real expectations, and at what point do we start to lose them or let them down? Well, luckily for us, there's been a lot of great studies on this, so we have a lot of data. Acme, for those of you who don't know, it's one of the largest CDNs in the world. They've done a pretty extensive study on user expectations, and what they kind of found was that 47% of people expect a web page to load in 2 seconds or less. So it's not a lot of time. I'm sure plenty of us in this room have built products or websites that load in a much larger time than that. Google has also done similar studies and found similar things. Google's study was more based on e-commerce, but what they really found was that shoppers expect pages to load in 2 seconds or fewer also. But in addition to that, they found that at 3 seconds, a large share actually start to abandon your website. So go to other places, go to your competitors. And no matter what your opinion of Facebook's Instant Articles feature, performance was definitely the impetus behind it. Facebook realized that the average website's pretty slow, so they kind of took it upon themselves to try to resolve this issue. Obviously, this gave Facebook the added benefit that they can keep users behind their gated walls, but it also serves their users by giving them that better, faster experience that they really craved. So why do people care about this so much beyond just the fact that, that they can perceive time well? Really, it's because savings in time feels like simplicity to people. And that's what people want. They want your app or site to simplify their lives, whether it's a tool simplifying their workflow or just entertainment that they want to work on demand as they want it and not be difficult to use. They want it to simplify their lives. So all this really just shows us that performance is not just what users want, it's what they expect. Good performance is good for our users. And when it comes to mobile, if you're kind of in that space, which everyone is nowadays, where slower connections are still common, most studies actually show that users want faster mobile websites than their desktop counterpart. So we have slower connections to deal with and people expecting faster sites. So what about the business side of things? The money. The thing that's very important people care about. How does performance affect conversions and revenue? Again, here we have a lot of different evidence from a lot of different places. Walmart's done pretty extensive studies on this, testing their mobile e-commerce platform, and they found that for every 100 milliseconds they could shave off of load time, it increased revenue 1% incrementally. So looking at this over kind of a 0 to 15 second range of loading, you can kind of see what happens. The big dip kind of happens between that 100 milliseconds and 2 second range where people go from perceiving something as being instant to context switching while waiting. And for Walmart, that range represents about a 5% swing in revenue. So by making their pages 500 milliseconds faster, they gained 5% in revenue. And what kind of stakeholder would enjoy those numbers? Amazon's also studied this pretty extensively. And what they found is almost identical, but what you'll notice is it's actually kind of the inverse. They tested adding time to their page load. So for every 100 milliseconds they added to their site, they actually lost 1% in revenue. So almost identical, just kind of the inverse thing. Etsy, who has a great performance team, and we've actually kind of based a lot of what we've done on their prior research, they looked more at page weight. Now, page weight obviously isn't something directly perceivable to our users. Nobody's going in and looking at total page weight, except for maybe other developers who are just curious. But it does correlate to performance. And what Etsy kind of found was that by adding 160K to their page size, they actually increased mobile bounce rate by 12%. So 12% more people were leaving their mobile site. And 160K isn't a ton. That's might be a couple images on Etsy's website. Mozilla, who's actually a client of ours, caveat, has done some testing as well, and this doesn't just affect e-commerce. Mozilla tested performance on their Firefox download pages, and they really found that by shaving off 2.2 seconds off their load time, they increased downloads by 15%. So if you've got a product landing page and you're trying to get conversions and people to download your software, cutting off load time can definitely help you there. And of course, it's important to note that it affects politics as well. During the last election cycle, the Obama campaign looked at making their donations pages faster. They managed to make them 60% faster without changing much else, and it increased donations by 14%. So it affects a lot of different worlds. So revenue, downloads, donations, whatever your conversion metric happens to be, a good percentage of it can be tied to performance. So much so that Microsoft actually found that 250 milliseconds is the magic number for competitive advantage. So if you can beat your competitor by 250 milliseconds, you have a distinct advantage on the web. If you're 250 milliseconds slower, you have a distinct disadvantage. Again, not talking huge numbers here. So for a user, what impacts performance? Well, there's some obvious ones most of us know. Big obvious one, network speed. You're obviously going to have a much better time on Google Fiber than if you're on the edge network out somewhere roaming in the middle of nowhere. Or things like the browser or device you're on. Browsers and devices have a myriad of different performance issues, everything from their JavaScript performance to iOS even has a weird 300 millisecond delay on click actions, which creates kind of a perceived performance issue. But network speed, browser, and device are all things we as developers don't necessarily have control over. We can't force our users to use Chrome on the latest MacBook Pro on a Google Fiber connection. All we can simply do is pick a baseline. So go ahead and look at our analytics, see what devices are users on, what connection speeds are they on, and what browsers are they using, and set our baseline based on that, and then work within those constraints. But there are a whole host of other things that we do have control over. So some that I'm not going to touch on a ton today, but obviously if we look at our server, it's going to affect our speed, the CMS we choose to use, our database infrastructure, and then things like number of asset requests. So how many requests you're making for images, fonts, CSS, JavaScript, the file size of those assets, so how big are they, and the way we're loading them. Are we lazy loading them as needed, or are we just throwing everything out front? Repaints also affect performance, so if we're doing stuff with CSS, requiring a repaint, it's obviously going to be slower than if we can do it in a way that doesn't, and then user perception plays into it as well. So looking at number of asset requests, some of this will change obviously with HTTP2, but for the time being at least, it's simple. The less requests you can make, the better. The faster your page is going to load if you have less requests. And when it comes to file size, obviously the smaller the better. But despite knowing this, the size of websites just continues to grow. So this is a chart of, I don't know, it might be kind of tough to see, but essentially the average web page size from January 1995 to July 2014. And you can see it just makes a straight hockey stick up. Or, as in the words of Jason Grigsby, we've kind of remade the internet in our own image, which is to say obese. Now, to be fair, part of this complexity is just part of this increase in size is just due to the complexity of our tools and apps nowadays. Obviously, what we're building now is more complex than what people were building in 1995. But part of it is also due to developers using some of these monolithic frameworks and tools without really questioning their downside. So really on this, it's just making sure before you're loading anything in, whether it be jQuery or React or some other framework, that you're doing it for a good reason, for a true need and not just as a crutch. Because really the only thing you're doing is penalizing your users. But if something is just truly an issue of complexity, you do need that framework, we can look to other measures. So like I said, the way we're loading assets. So utilizing things like lazy loading and loading images or other file requests as they're needed by the users and not all up front is a good way to do that. Or we can even look to things like design as a way to handle performance. So kind of up until this point, everything I've been talking about has kind of been objective time. It is kind of important to note that there are two different types, though. There's objective and psychological. So as good as people are at kind of perceiving basic loading, there are ways to make them feel like they're in that instantaneous or the machine is working state when maybe they've really moved into a context switching state. So as you can see here, kind of a little psychological design trick. These two things are taking the exact amount of time, but we can make one feel faster than the other. So that's kind of the causes of a lot of our performance issues, but how do we actually ensure fast websites? Well, what we've kind of landed on is there's two different important things you can do. The first is to discuss performance and discuss it in a way that benefits the project and sets the project requirements. And the second is to make it visible to the organization as a whole. So how do we best discuss performance? Well, we can do it from the start, for one thing. So I don't know if this looks familiar to anyone in the room, but too often performance is only really considered a problem of the dev team. Nobody discusses it up until that point. Often a project goes through proposal, discovery, design, before anyone really stops to think, how is this going to affect performance? And when in reality, performance really needs to be discussed from the earliest stages. We need to move it up to the front. Even jumping in from the beginning and saying things such as, the goal of this project is to create a beautiful, data-driven, personalized, lightning-fast experience. It may not seem like much, but starting to get that mindset in there really does a lot. And you want to keep that going throughout the project. So like I said, when we're discussing performance, we definitely want to do it from the start. The other thing we definitely want to do is to educate our stakeholders on the importance. So get those important people to care about it. And this is where we can bring in a lot of those stats. There's a ton of them out there. I only shared a few. But if you bring those in and tie it to actual revenue, you can do a lot to convince people. And once you start doing this more on your own, actually having your own stats and collecting that information and saying this is how we've actually done it and improved revenue becomes even more powerful than just random stats. Like I said, you want to make performance a project goal. And so don't just stop at putting in your proposal that we want to make a lightning-fast website. Actually make it a project goal, and you can do that by including actual performance goals in your project requirements. And one of the good ways to do that is through establishing a performance budget. So what is a performance budget? It's a framework to inform and enhance performance discussions. It can serve as a point of reference as you decide maybe what components should or shouldn't get added to your project, or maybe just how those components are implemented. It can provide justification to your stakeholders around maybe why you did something a certain way. And it really just keeps you focused on performance throughout the project lifecycle. In short, a performance budget works a lot like your typical household budget. This is not my actual Mint budget. This is a search from Google Images. I think that's actually a couple of years old. But a performance budget works a lot like this. As everyone knows, in your typical household budget, you have limits on what you can spend in different categories. So you have limits on groceries and coffee shops. And if you go over budget in one, you might have to spend less than another. So you can see in this example, they've gone over in groceries, so maybe they've got to cut back on their coffee shop spending. But whereas in your typical household budget, you may be looking at things like groceries and your mortgage. In a performance budget, we're instead looking at things like file weights and render timings. So it's essentially just a limit on certain time-related operations. So this is kind of an example of a basic performance budget. And in this, we've got a few different render timings here. Start render, document complete, and fully loaded. And we'll come back to each of these in a second. I'll go kind of deeper into what each of those is. But this is kind of the basis of what a performance budget would look like. It gives us our target render timings and some target weights to hit. But first, let's look at when we should establish our budget. Just like it's important to start discussing performance early, it's equally important to set your budget early. So typically how we've started doing these and where we've started setting them is in our discovery phase, before any design or development of a new component, page, feature, site, or app has really begun. And we set it here because of this. If you set it before, or if you set it after design, or after you started actually developing your components, there's not much you can really do. It'd be like setting your budget after you, on day 22 of the month after you spent most of your money. It just doesn't do you a lot of good. So it's important to set it early before you actually start spending those things. And again, those are render timings and file sizes. So before we would actually get started on setting a performance budget, we have to answer a few questions. So one is we have to determine our browser baseline. So again, this goes back to we can't dictate what browsers our users are using. We need to look at analytics and see what they're using and pick the lowest common denominator browser that we're willing to support. We also have to determine a baseline connection speed. So do we want to support a 3G connection? Do we only want to support a faster connection than that? It depends on where our users are at, how this is being used. The next thing we kind of want to look at is weighted multipliers for maybe different environments. And this kind of came out of when we started doing these. The first one we kind of rolled out, we didn't think about this. And we set our budget, and then we realized, our alpha environment, our beta environment, and our production environment all run at different speeds. So it became kind of difficult to actually use. And so one of the things we started doing was this, where we kind of figure out those different speeds and actually set weighted multipliers so everything makes sense across the project development cycle. And then 4, you kind of want to look at, are you just measuring for time of launch, or do you need actual continuous testing? So it kind of depends on your project, your scenario. If you're doing more of a product and you're continuously updating it, you probably want to include some type of continuous testing on your performance. So as you add new features, you can check whether you're over or under your budget. So once you kind of have those questions answered, you can kind of start to establish your budget. And the way we've done this is by looking at competitors. So why do we want to validate performance against our competitors? It's because there isn't necessarily a magic number we want to hit. We just want to beat our competitors to get that competitive advantage, that 250 millisecond advantage or so, like Microsoft has stated. So we identify our main competitors, and then we kind of analyze them, their performance of their websites using a performance tool. The tool we use personally is webpagetest.org. It's an open source project developed and maintained by Google. And essentially you can drop in a URL, I'll show you a demo here in a second, and it spits back a ton of useful performance metrics. And then we want to record those render timings, start render, document complete, and fully loaded. And then we want to benchmark our own site based on the needs of our fastest competitors. So let's look at each of those render timings for those of you who may not be familiar. The first one we want to look at is start render. Start render is essentially the first point in time that something displays on screen. So before this point in time, the user was just staring at a blank page. Start render is really important to look at because it gets into that perception of something happening fast. As long as something's taking place on screen, we kind of keep our users and we don't lose them. So that's very important to look at. The other one is document complete, and this is what the browser considers the page loaded. So the onload event, essentially. Usually, this means that all of the images and content have loaded, but may not include content that's triggered by any JavaScript execution. And then the last one we want to look at is fully loaded. And fully loaded is essentially when it's actually complete. It's any activity that's triggered by JavaScript after document complete. So just to run through kind of an example here, DEG, we're actually currently redesigning our own website, and we wanted to create a performance budget for this like we do for everything else. So we went in and identified some competitors that we wanted to outperform speed-wise, so throwing up some random other agencies here, but we identified our competitors that we wanted to beat speed-wise. We ran them through a performance analyzation tool, so like I said, we use web page speed test. We picked the baseline browser we wanted to support. And there's a bunch of other options with web page speed test, but the main ones here are device and kind of connection speed. And it'll analyze their whole website and spit you back some good information. So I don't know how easy it is to see, but the green highlighted ones, it gives us back those start render times, the document complete time, and the fully loaded time. So once we kind of have those numbers back, we record them in a Google Doc tool that we kind of use to calculate target file sizes based on a combination of benchmarks and baseline network speeds. Now, this tool we use is just one available, and it was actually created by, running through the demo here. The tool we use is actually created by a guy by the name of Dan Mall. It's actually out online. He keeps it on Google Docs. You can make a copy of it and use it yourself. But it's just one tool that's out there. Another one that was released recently was performancebudget.io. It works kind of similar, but the inverse. Essentially, say, I want my site to load in X many seconds on this connection, and then it kind of gives you, okay, your performance budget for that is 195 KB. You can kind of play with the sliders. So I've got, okay, this much JavaScript, this many KB in images, and kind of create your budget that way, and then it spits back, okay, here's your estimated load times on these different connections. So that's performancebudget.io. There's a couple different tools, but like I said, we use Dan's tool, and it basically calculates target speed to be 20% better than our competitors, and we really liked it because of that. And why is 20% important? 20% is when people can really start to perceive a difference in speed. So kind of the numbers I went over at the start where people can speed, that's looking at a single instance, but if we're looking at comparing ourselves to others, 20% better is really where that performance becomes noticeable. So we really want to go beyond this as much as possible, but 20% is that point that we have to get to at least to have that competitive advantage. So we're identifying competitors, and you might be saying, but my competitors' websites are really slow. Maybe you're already the leader in this space, in the industry, performance-wise, and there's nowhere you can go from there. We've run into this a couple times, and I'd say, one, what a great problem to have. You're already ahead of the pack. But two, you can't just let that stop you from making an even faster site. You can go even beyond that and make it even more difficult for your competitors to catch up. So like I said, we've run into this case on several occasions. The way we've kind of handled it is we've identified competitors in similar verticals. Maybe they're not direct competitors, but they were close enough verticals where it still made sense, and they had great numbers, and so we kind of benchmarked ourselves against those. So we can calculate target weights and times to hit, great, but where do we actually go from here? How do we actually use this? What happens when we need to add a feature to a site that's going to break our performance budget? Say this carousel of Fonzie jumping the shark. Really what we want to do is just make sure that once we set our budget and once it's been established, the project sticks to its goals. Which, going back to the example of adding a feature, gives us a few options with how to proceed. If this feature is going to break our performance budget, the first option we can do is to optimize an existing feature. So maybe there's a feature on the site that performance wasn't really considered for in the past, and we can go back and refactor it in a way that still gets us back under our budget. So first thing, go back and look at what we can refactor to make better. Two is we can remove an existing feature. Maybe it's as simple as this is replacing some other feature, so it's not a problem. But maybe we look at a performance budget and we look at the numbers and say, hey, a faster website in this area is going to give us more benefit than this other feature, so kill the feature that's not doing much good in the first place. Similarly, we can not add the new feature. Maybe that trade-off isn't worth it, and we want to keep that performance there for monetary reasons. And fourth, I know I just said to stick to the budget, but fourth is a valid option sometimes, and that's to blow the budget. Like with anything, performance isn't necessarily a black and white thing. There are other factors, reliability, usability, just other quality factors that sometimes outweigh performance. So it's not the be-all, end-all. It's something very important to look at, but like with anything, the point of a performance budget is to allow you to make kind of intelligent, smart choices about how you're doing things and not to just say this is a black and white issue. So taking performance kind of one step further, doing it for an entire website is great, and it's the simplest approach, but you can also get more fine-grained by setting page-level or even feature performance budgets. So maybe you have a website and you have a search page that needs to be much faster than a listing page, for instance. It makes perfectly good sense and is a great thing to do if you can say, okay, we want to set the performance budget for the search page to this, and for the listing page, it only has to be for this. So getting more fine-grained like that definitely helps improve performance overall. So to kind of recap on discussing performance, we want to make sure we're kind of thinking about it from the start. We want to educate our stakeholders on the importance, so bringing in those statistics, whether they be from other sources or if we can pull our own from past experiences or on our own product. And we want to make performance a project goal, and we can do that by kind of establishing a performance budget to help guide decisions and help us stick to those goals. So like I said, discussing performance, kind of the first main thing we want to do to ensure fast performance. The second thing we want to do is to make performance visible. Now, a lot of times in our organizations, performance is something that is invisible. Typically, a lot of us and our stakeholders are on the highest quality tools and the highest quality connections, and we don't really notice these issues. But we have to remember that most of the time anyway, we aren't our users. So making performance visible is one of the best ways to get our peers and leaders to notice that it's important. And why is it one of the best ways? It's because it creates a culture around performance. You won't get very far in your organization when it comes to performance unless you get your whole team or your whole organization to actually care about it. So how do we make performance visible? One of the best ways when we're looking at doing performance in our developer peers is to surface performance in our workflow. So one of the tools that we've started to use was created by Tim Cadillac, and it's called Grunt Perf Budget. And if you use Grunt, which like we do in our workflow, it's great, and it basically hooks into the web page test API, which handily has a node wrapper, and spits you back either warnings, passes, or fails whenever you do a Grunt build based on your performance budget, whether a feature falls within or outside of your budget. So this is great for that. One of the things that Tim has also mentioned doing, which we kind of appropriated from him, he mentioned this in a blog post but didn't actually release it, so we just kind of built it ourselves, which is to create an indicator in your build tool. So one of the tools our front-end team uses is Pattern Lab. For those of you not familiar, it's kind of a design methodology and a tool to kind of build out the front end of websites. We've built an indicator into that using the navigation timing API, which allows us to get back quite a few different metrics. So essentially, it just is green if we're in the good and red if we need to look at something or refactor something. While this doesn't necessarily give us the added benefit that web page tests would, setting baselines, et cetera, it at least lets you set an approximate visual indicator and know where you're at in relation to your budget. Etsy is a similar tool that they built into their dev environment and they swear by. So anyone working on Etsy within the Etsy walls kind of sees this on top of the website. So they surface the data for their team. They can kind of see the total times they're at, and then they clearly state this either violates their performance expectations or it's within it. Surfacing it in our tools, whether it be a build task or an visual indicator, is a great way to work with our developers. Surfacing it in reporting is a good way also to work with other people. So currently, we're looking at hooking up performance budgets into Jenkins, which we use for our continuous deployment. Web page test, as I said, has a great API. So basically through this, we can look at generating a report anytime we deploy. This gives us the benefit of continuous reporting as new features are added. I don't have an example of our own yet because we're just working on this now, but a lot of other companies do this. So Lonely Planet has one that they actually have online where they have a CSS report and they also have a JavaScript report. They mostly look at file sizes and they look at it over trends of a month, a week, and a day. And you have a nice visual indicator there of, the community page is becoming a problem. It's grown too much over that time period. Etsy does something similar. They report on timings in addition to file sizes. They look at both server-side performance and front end. And these reports are great, but reports, as you know, can be somewhat hidden if we're spitting back this huge thing that people may ignore or not look at it. So you really have to work to get the cadence and delivery right on how you're doing these reports. You don't want to overwhelm with data or hide them where no one's actually looking. So one idea that we've come up with and other people have looked at doing that we think would be a good way to cut down on overwhelming with data is sending one actionable stat per week to those very important people, our stakeholders. So it may be looking at the example before that a certain page has grown and ballooned too much over the past week or the past month, and sending actionable items we can do to fix that problem instead of sending a huge report. So surfacing performance in our tools and our reporting help to do amazing things. They get people thinking about it a lot more. But by far the most transparent way to make performance visual that I've seen is this. This is how Etsy does it. They actually have monitors on the walls of the Etsy building. And they loop through and ping their site at different connection speeds and display that back. In addition to connection speeds, they look at the same thing by location. Sorry, Australia, apparently you have a slow Etsy experience. And displaying performance in this visual way just really keeps it close to mind. It keeps everybody empathizing with what their user experience actually is. Another great way to do this is to compare your site to others. So if you're going to display it somewhere on the screen within your company, you could look at how does our site feel to our users compared to how our site would, or how another site would feel to our users, so our competitor's site would feel, and just really compare the two. You can do this with web page tests, hook into their API. Obviously, you can kind of pull this back, and you could display these different things visually. So how do we ensure fast websites? Well, one is to sell stakeholders on the importance. As I said, performance is often something that's invisible to people if they aren't already thinking about it. So sell them on the stats of why it's important. Consider performance from the start. So once you sell the stakeholders, you can get this moved outside of just the dev team and into the whole organization. You can make good performance a goal, so getting it into your project requirements by establishing and maintaining a performance budget. And then also important is to make it visible. And the reason we really want to make it visible and why that's important is we want stakeholders to feel it. Most people inside our organizations, like I said, have high-powered laptops connected to high-speed connections. Getting them to empathize and feel the performance issues is one of the best ways we've found to build a culture that actually cares about this stuff. So, any questions?
So do you have any recommended tools for applications that might be behind like an authentication to where like the web page test wouldn't work?
We haven't actually dealt with that. Web page test is open source and has an API, so I'm sure you could hook into it that way and build off of that for those needs. But we haven't run into that, so I haven't really used anything that hits that kind of stuff.
So one of the things you mentioned was the tricks to like make the user feel like it was loading faster. How do you account for that in your budget? Obviously, if you know what I'm talking about.
Yeah. The budgets we kind of do don't consider that a lot. It's one of those things. A lot of the tricks with that, most of the time, we're doing it more. Less with loading, which our performance budgets more kind of address, and more with the actual interaction. So if you're doing something within the app, doing tricks there to make it feel faster, whether it's that kind of like iOS has the tap delay, you can do things to avoid that and that kind of stuff. So that stuff, a lot of times you hit more on the actual interactions and less than the loading. So really to answer, the performance budget doesn't necessarily consider that. Anyone else? Thank you.